Hello friends, welcome back. I am Rajneesh and today in this session we are going to understand Red Hat cluster suite. So let's try to understand this diagram. What this diagram says is it's a high availability web server. It means you have one nodes that are a part of cluster. So first of all, what is a node if we talk in terms of cluster? A node is a part of cluster on which your clustered service may run. A node is the device on which certain services which are required for cluster to be active must be running at any time. For example, cman or cluster manager is a service that should run on every clustered node. The service called fencing should be running on every of these clustered nodes. Why do we want cman? Cman is a basic set of services which are required to be present on any of the nodes so that they interact in the clustered environment. In case one of the nodes is not responsive, so the cluster or the cman will come to identify that this particular node is not sending any more messages, and it can then take the decision to reboot this clustered node. It can detach or it can just reboot using the fence service. Why do we need reboot? The first part that needs this reboot is the shared storage. Shared storage should never be used by more than one clustered nodes at the same time. It means that if we are talking about Red Hat environment and Red Hat high availability clustered environment, it is only one node that mounts that shared storage at any instance of time. Okay, let us understand what it means. First thing, if we are talking about a high availability web server, is the document root of the website. Document root of the website is a location where all of your web pages corresponding to a website are present. In case you are trying to run Apache service on clustered node 1, you should be able to see the same contents. The same contents should be visible in case you run Apache from node B. The same should happen for C, D, and E. To keep all of the data specifically related to document root to be synced in all these network environments, the best thing to use is to use the shared storage. That is, we can either use the fiber channel SAN that can be used to export LUNs to all these nodes. The other approach could be we can use iSCSI target that will be used to create a LUN which can be imported by any of these clustered nodes. So as soon as this clustered node boots up, they should have the accessibility to the shared storage. For example, we have a device slash dev slash xyz. The same device should be available by the same name to all these clustered nodes. Whether we are making use of iSCSI target or whether we are making use of fiber channel SAN, it doesn't matter. The thing that matters is the shared storage. The block device, the shared block device should be accessible as soon as any of the nodes boot up, and the name of the shared block device should exactly be the same on all these nodes. Okay, so first part is done. We format this learn using any of the file systems. In case you want it to be accessible by more than one nodes at the same time, we can make use of global file system that supports multiple journals on it. But if we are talking about a Red Hat high availability cluster, it's actually uh, it's the cold failover that happens. It simply means that if we are talking about any of the clustered service, for example, clustered web server, so Apache is going to run on any of these nodes, not on all the nodes. So whichever node will have the active web server is going to act as an active node, which will be assigned the IP address that will be used by the clients. For example, let's consider the scenario when clients are trying to browse the website www.labs.com. So what will happen is www.labs.com is going to resolve to its IP address. Suppose it's 1.1.1.1. So effectively the clients reach the public IP address of this clustered environment. Now this public IP address will be assigned to the node that has actively this clustered service running on it. This 1.1.1.1 is going to be the floating IP address that will be assigned to the node which is presently active. In other words, we can say that this device has got IP address 1.1.1.2, this has 1.1.1.3, this 4, 5 and 6. So finally all these nodes have different IP address, but there is one floating IP address which will be used by the clients, or which will have the A record that is pointing to the server which would be active. For example, it's 1.1.1.1, which is not assigned to any of the nodes physically. Clustered service will be responsible for assigning the IP address to the node which becomes active. So whichever node becomes active, for example this one becomes active, what it is going to do is it is going to assign that IP address to this node. It is going to mount the shared storage as a document root, and it will start web service from it. So finally, when the client is trying to access or browse the website, it will be browsed from node A. So what happens when this node becomes unresponsive? As soon as this node becomes unresponsive, the service cman, which is responsible for sending the messages to the complete clustered environment, the cman on the cluster environment will come to know that we are not receiving any messages from node A. And after that, depending upon certain parameters, upon the time till which we don't receive any kind of response from node A, after that timeout is completed, the cman will come to know node A is not responding anymore. So what cman is going to do is it's going to run fence D, or it's going to fence this node A. Fencing basically means you are detaching the shared storage from this device. Why do we need it? Because there may be some kind of heavy load on node A. It may not be responsive for a few minutes, and it may become responsive once again, and it starts writing to the shared storage. In case this happens and other node mounts it and they also start writing to it, so you may have inconsistent data in it. So that's the reason, as soon as you have a node that is identified to be non-responsive, cman takes care of it and fence that device, detaches the shared storage from it, and relocate the service or the clustered service, which is your clustered web service, to the other node that could be of highest priority among the left out nodes. So now the clustered service is going to be relocated to this one. It simply means it will mount the shared storage as a document root, it will start Apache web service, and the floating IP address 1.1.1.1 is going to be assigned to it. And this node has been fenced. Fencing means it is a kind of hard reboot, and the machine, as soon as it comes up, will join the cluster if everything is fine. Okay, so here is the network power switch that we are discussing about. Network power switch is the switch that is used to reboot or to fence the device. Fencing could be done by multiple means. It could make use of your VMware agents to connect and reboot a particular node. It can make use of network power switch. Network power switch is actually a power switch that is used to connect all the nodes to it. And finally, the fence D service running of any of the nodes can make use of the power switch to switch off or reboot any of the nodes which is not responsive. So the fencing is done in this environment using network power switch. But in our environment, what we are going to use is virtual fencing that we are going to use, because we will be having KVM based environment representing it. So this is how it works. Coming on to the generic considerations before we set up a Red Hat cluster suite. In case you are setting up any kind of clustered environment, the first thing to be noted is there should not be a single point of failure. It means that every node that you have should have multiple NICs that should be bonded together, so that in case one of the NICs gets faulty or the Ethernet interface that is connected to that particular link gets disconnected, so the network will still be available. So you should have a bonding that should be enabled on the network interface. You should have multiple RAID controllers, so that in case one of the RAID controller goes down, other RAID controller can be used to access the disk and to keep the node in up state. You should have multiple processors. In case one of the processor goes down, you still have the other processor that continue to make it run. You should have multiple paths from nodes to the shared storage. So you should have multiple paths to fetch out the LUN from the shared storage, so that even in case one of the path goes down due to any of the reason, the other path will still be accessible and the service will continue to run on the same node. And finally, you should have redundant UPS, redundant uninterruptible power supply, so that in case one of your power supply goes down, there is still another power supply which will keep the server running. Data integrity. This is the most important part of your cluster. So, if you are talking about the shared storage or the shared partition, that should be accessible, that should be mounted only on the node which is active and on which the clustered service is running. In case this node is active, this should have the shared partition mounted and it's working on it. So as soon as it becomes unresponsive, the node will be fenced by cman and it will be immediately disconnected from the shared storage, and the shared storage will now be mounted on another device which becomes active. So finally, at any instance of time, the shared storage will be mounted only on the server on which the clustered service is active. So fencing disconnects the other node instantly or immediately, so that the data doesn't become corrupted. One more important part is whether you are talking about the network switch or whether you are talking about any other kind of fencing. The thing is, if you are fencing a particular node, that should be fenced immediately. That should be immediately disconnected from the shared storage. We have ACPI service, advanced configuration and power interface service, that runs on every of your Linux machine. So that should be disabled. The reason is, in case you are trying to send a power down signal or reboot system signal to a particular node, that may do a safe reboot in case you have ACPI running on it. And the safe reboot is going to take some of time, and maybe uh, till the time it's not rebooted properly, it has the shared storage mounted inside it. So the same shared storage should not be mounted on other in read write mode at that time. Other thing is, in case this node 1 gets hung up due to any of the reason, it may still continue to have the access to the shared storage, which is still not good. So finally ACPI should be disabled so that it's immediately kicked out and rebooted like a hard reboot. Other thing is, in some of the servers you have an option in the BIOS where you can just disable the safe reboot, or yeah, there is some option which says safe power off, that should be disabled, so it should be immediately rebooted. If both of these things doesn't work, you may have to add a new kernel parameter which is ACPI equal to off in the current kernel command line in grub.conf. Other thing that we need to take care of is network manager should be disabled. Network manager is a service that is generally used on the Linux desktops to provide a good user interface to manage your network interfaces. It's not supported on the servers, so you are requested not to make use of it. It's best if you just switch off this network manager service, and if you want you can just uninstall the package. Your network, the network switches that we are using in our environment, should support multicasting and internet group messaging protocol, because Siemens service that runs on every of the clustered nodes interact with each other nodes, or the messages are sent between these nodes using multicasting and IGMP protocol. Sorry. So what actually is a cluster? Cluster is a combination of one or more computers or one of more nodes. Any server which is a part of cluster is known as node or a clustered node. Sorry. So finally, cluster means a group of computer nodes that interact with each other to perform a specific task. Storage, we have already seen, it should be able to provide you consistent file system image across the servers in the cluster. High availability, as the name suggests, highly available web service or highly available any service. In case one of the node goes down or service on one of the clustered node goes down, the clustered service will still be accessible. Sorry. Okay, keeping this environment in mind, in case Apache crashes on this server or this server crashes, the service will be relocated to node 2 and it will continue running the web service now. So this is effectively your high availability service, because the service will be relocated to it, and from the client's end it will still be visible that the same website www.labs.com is accessible, and he'll not come to know that it has been migrated to the other node. So this is high availability. Continuous availability of services by eliminating single point of failure. So other kind of cluster could be load balancing cluster. In load balancing cluster, what actually happens is when a request comes to your server or the firewall, it's distributed among multiple nodes. So effectively, in load balancing environment, you have a web service running on all of these nodes, and all of the nodes should be having access to the same shared storage. So here we need to have, or we need to make use of global file system, because all the nodes in the cluster should be able to mount that particular shared storage. So here the uh, service should be present, or the firewall is present, which is responsible for the load balancing of the service between these multiple nodes. It could make use of different algorithms that define how much traffic should be sent to which server. Dispatch network requests to multiple cluster nodes to balance the load request among clustered nodes. Additionally, it provides scalability. You can add more of the servers. High performance clusters. So it effectively uses cluster nodes to perform concurrent calculations on all the nodes. So yeah, here we have an example of, sorry, here we have an example of load balancing cluster, where we have the clustered nodes present over here. Here is the client that is trying to access it, Linux virtual server. So effectively, when the client is trying to access it, it's making use of the floating IP address. Sorry. So finally, this active and backup router are able to take care of distributing the requests between the clustered nodes. So clients don't have any visibility of which server they are trying to access. Rather, they are making use of the IP address, which is floating between these two backup routers. And finally, these backup routers are responsible for distributing the requests between the clustered nodes. Okay, major components of any cluster. One is the clustered infrastructure, which means the basic set of clustered services that should run on any of the clustered node. High availability service manager like RG manager, which is responsible for taking care of high availability of any service and should be able to relocate the service from one node to another. Red Hat global file system. This has a feature that it supports mounting of the same file system on multiple nodes because it has multiple journals in it. Clustered LVM. This provides the same feature as the clustering as the LVM on a single node. But the difference is that whenever you are trying to modify an LVM from any of the node, the same metadata should be propagated to all the nodes in the cluster. So that happens, or that is taken care of by the CLVMD service. And for that you need to modify lvm.conf for a parameter that says make use of clustered LVM, that we'll see in the lab. Global network block device. Here you create a global network block device that is exported by one of the servers and is imported by the other server in the same clustered environment. This is not generally used, so we are not able to look much into it. Cluster administration tools. These are the set of utilities that we are going to make use of when interacting with a clustered environment, or when we are running some commands from any of the clustered nodes. Linux virtual server is the service that is used for load balancing between these clustered nodes. So clustered infrastructure, it provides the basic set of functions for a group of computers or the nodes to work together as a cluster. The most important part is cluster manager, or the cman service that runs on every node. Second is distributed lock management, that is managed by lock management. Fencing is a service that should be present on any node so that they are able to disconnect the other node from the shared storage, or it could be different kind of fencing methods that could be used that we will see. For example, we have an ESX environment. It could be ESX kind of fencing. For Zen, it's different fencing. For ILO based fencing, it could be different, but logically, it says you are detaching the shared storage and you are hard rebooting the other node which is not responsive. Cluster configuration management. This is a service which is responsible for keeping the configuration of all the nodes in sync. CCSD is the service that is responsible for it, and the configuration file associated is /etc cluster cluster.conf. The configuration file should be same on all the clustered nodes. So cluster infrastructure provides the fundamental functions of the nodes to work together as a cluster. It includes configuration file management /etc cluster cluster.conf that should be consistent across all the nodes in a cluster. Membership management in case one of the node is not responding, that is, we don't receive any kind of message from other node, it should be able to identify that. So membership management, a new node joins the cluster infrastructure, leaves the cluster infrastructure, it's managed by cluster infrastructure. Lock management, and finally fencing the unresponsive device. High availability service management provides failover of service from one cluster node to another in case a node becomes inoperative. For example, RG Manager. Cluster admin tools for configuration and management tools for setting up, configuring and managing clusters. LVS running software, a routing software that provides IP load balancing. LVS runs on a pair of redundant server that distribute client requests evenly to the real server. It depends upon the kind of algorithm that we are using. So cluster manager manages cluster, quorum and cluster membership. Cman distributed cluster manager, and it runs on every clustered node. It keeps track of cluster quorum by monitoring the count of cluster nodes, or the cluster votes in case the votes are greater than 50%. So quorum via ethernet, quorum consists of 50% of nodes, 50% of votes plus 1. In case we have more than 50% of votes, the cluster is active, or we can say it's correct, and clustered service is running. If we have the number of votes equal to 50% or less than that, the quorum will not be correct and the clustered service will not run. Why do we need to have this restriction? This restriction should be there to prevent the split brain condition. It means, for example, let's consider a scenario when we have 4 nodes and 2 nodes are up, or 2 nodes are accessible by the cman and two nodes are not accessible. So it cannot correlate, or it cannot start the clustered service on these two nodes, because you may have the same cluster running on these two nodes, and in case these other two nodes which are not accessible to these two nodes may be up and may bring up their own cluster, and finally it leads to inconsistent data, because they both of them may share the same shared storage. It prevents split brain condition, because in case we have less than 50% of nodes that are able to create the cluster, we can have more than one clusters in the same clustered environment. Quorum via disk. We can additionally provide some additional votes by means of heuristics. Whether a particular device is visible or not, try to pinging a particular device. We'll see it in the lab. By default, every node has one vote, but there is possibility that you can assign more than one node's votes to a particular node depending upon its performance. Cluster resources. Cluster resources are the parts of the clustered service. For example, IP address. If you are having three, or let's say three nodes in a clustered environment, you may have IP address 1, 2 and 3. There should be one floating IP address which is for that will be allotted to the node which becomes active with the clustered service. Script or service that is supposed to be run as a clustered service on a node, and the file system, the shared file system that should be present. Global file system. So what is a global file system? It provides a distributed metadata and multiple journals for optimal operation on a cluster. It means GFS has been designed in such a way that it is accessible and mounted in read write mode by more than one clustered nodes. However, it can be used on the standalone node also, but it's not supported and not required till the time that node is not a part of a cluster. So it's basically responsible for maintaining file system integrity. It uses a distributed lock manager to prevent the data consistent. Change is immediately visible to the other clustered node as soon as you modify it on that node. It eliminates the need for redundant copies of application data. No duplication is required. Enables concurrent read and write access to the data by many clients. Simplifies backup and disaster recovery, as we have only one location where the data is stored. Now, coming on to the lab environment. The kind of environment that we have in our lab is, this is our base machine on which RHEL 6.3 is installed. This base machine actually has three interfaces. One is NIC1, which is actually a channel or a network that is used to access shared storage. So NIC1 we say it's SAN 0 network. NIC2 we say it's SAN 1 network. And both these networks can be used to reach to the same shared storage. So finally we have implemented multipathing in our lab environment. That is, we are going to export one learn that is going to be accessible by node 10 as well as node 11, and the same learn can be accessed through SAN 0 interface as well as through SAN 1 interface. So it will be multipathing. The same is accessible, same block device is accessible to node 11 also. Now the third interface is BR0, or it's a bridge interface that is going to work as a switch to connect node 10, node 11 and Lucy. So okay, that is going to connect these three nodes to the third switch. So implementing this high availability environment, we are going to make use of Kunga project as Red Hat users. So that simply says there are two applications. One is Ricky, which needs to be installed on every node of the cluster, and other part is Lucy, which is just your management interface. So it allows you, or it provides you a good user interface that can be used to interact with these clustered nodes. It provides you a user interface that can be used to manage these clustered nodes. Finally, you are not required to work much using the command prompt as far as you have Lucy in working condition. So this server is required till the time you are trying to modify anything, or when you are trying to relocate the service, or you are trying to modify the configuration. Otherwise this Lucy interface will not be required. Even if you want to manage the cluster nodes, still there are a set of clustered commands that can be used or run directly on the nodes. So Lucy is basically a user interface that provides you easy interface for the management of configuration.